Design patterns are how software engineers communicate with other software engineers about the code they're planning on writing or have written without actually having to show each other the code base. My name is Adi. I'm a software engineer at Amazon, and in this video, we're going to explain how do design patterns actually work, and we're going to cover 7 major design patterns under the 3 major buckets. Now, design patterns can be broken down into creational patterns, behavioral patterns, and structural patterns. And we're going to start off with creational, and specifically the singleton pattern. So, singleton pattern is like having exactly one head chef who controls all the recipes. No matter how many times someone yells, "Where's the head chef?" you get the same person, and there's only one. This is crucial when you need one single source of truth. Think about how Stripe, which is a payment processing system, handles your payment configuration object, or how your app has only one database connection pool. You don't want like 5 different chefs in the kitchen all claiming to be the head chef and being in charge and then contradicting each other, because that confuses everyone. Next, we have the factory pattern, which is like your logistics dispatch center. When someone needs to ship a container, they don't specify, "I need a 40-foot cargo ship with a specific like hull configuration." They just say like, "Move this from India to America." And the dispatch center decides whether that goes by like truck to the port, then container ship across the Pacific, or maybe it's just a small load that just goes straight by flight. Same with software. When Amazon needs to deliver a package, the factory decides the transport method without the ordering system caring about all those details. FedEx uses the same method to transport your packages either by truck, freight, or even like local van. And factories add abstraction, which becomes like a small issue, which means you're not directly in control of like the objects that are like being used. You can't actually say this is going to go by truck, this is going to go by ship, but you gain massive flexibility when new transport methods appear, suddenly needing to support drone delivery. Now, the builder pattern is the next one we're going to cover, and the last one of the creational patterns. And it's essentially like creating a custom house. Instead of getting like a pre-made house, where you have everything already created, you go to a builder and they say like, "Do you want brick walls or do you want wood walls? Do you want like a pitched roof or do you want a flat roof?" And you create every component step by step. And then at the end, you ask for the result, the final house, and you get what you asked, like created. And Notion uses this for creating documents. You can add text blocks, you can add database blocks, and then at the end, it renders out the final page. Now, the alternative is a constructor, with 15 parameters, but you have to remember where every single argument is, what's the type of every argument, and it gets really cumbersome and unmaintainable. Builders make complex object construction readable, but they do add extra classes to manage versus just calling one to create the house directly. The next types of design patterns are behavioral patterns. And the first one we're going to cover is the observer pattern, which is like subscribing to a newspaper. When a new issue gets published, it shows up directly at your doorstep. You don't have to go to the newsstand every morning asking, "Is the newspaper here? Is it ready?" And then just keep asking it over and over again until it does appear, which is essentially polling. You have one event, which is you subscribe, and then the second it's out, you get it. And you don't have to worry about this. YouTube follows this pattern actually. So when you upload a video, it notifies all your subscribers. It updates recommendations. It pings analytics. It does all those things. And it's all from one upload action. The alternative is polling, which is you keep asking, "Is the new video out? Is the new video out?" over and over again, which takes up a lot of time, a lot of CPU power. But the trade-off with observer pattern is memory. You have to keep in memory all the subscribers someone has, all the subscribers to those newspaper. But, memory is a lot cheaper than CPU often. Now, the strategy pattern is the last one we'll cover of behavioral patterns, which is choosing how you're going to get the final result you want when the final result is the exact same. But the strategy you use can make a big difference. Now, let's imagine you're going to the airport. You could go by bike, which is free, but will take 2 hours. You could go by bus, which is $3, but takes 45 minutes. Or you could drive there, which is $50 parking, but takes 20 minutes. They're different strategies, and they have different constraints based on time and money and your goal. But they always get to the same destination. So Google actually does this. So based on the distance you want to go or like the location you want to go to, they're going to get you to that location. But sometimes you ask to avoid highways. Sometimes you ask to avoid tolls. Sometimes you ask to be eco-friendly. And so they're going to look into all these different methods as long as but like they're going to make sure you get there on to the location. But it's going to make a difference on how fast you get there, how much money you have to spend to get there based on gas or whatever it may be. Uber does the same way. When you choose the destination you go to, but then choose the type of car you want, that is a strategy. You're choosing what strategy, what type of car you want to get to the final destination. Now, next, we're going to cover structural patterns, which is like, we're going to start with the decorator, basically, which is like a human. That's the human object. And then they're getting dressed up for weather. Now, you start with the base human object, but then you check the conditions. You say, is it like cold out? Is it raining out? And based on that, you wrap yourself either on a sweater, or if it's raining, you add a raincoat over that. And each layer adds like warmth or protection. And so a lot of video games actually use this. So video game characters have the base character model, and then you decorate it with armor for +10 defense, or like magic rings, or like boots of speed, whatever it may be. And the alternative is creating a separate class for every single combination. But if you have a lot of permutations, that can become a really large number very quickly. Instead, you can start with a base object and then just keep adding things on top of it. And so decorators keep things very clean and stackable, but they do add runtime overhead because when the program is running, you have to start making changes to the object. Whereas at compile time, you have the objects already created and you just pump them in and out. But the whole point behind these decorator patterns is really that they exist for thousands of engineers to be able to talk to one another and solve problems in a way that everyone understands. It's a framework of fixing the issue. And that's all that there is to it. You shouldn't always like try to force yourself to follow one of these patterns, but you'll find that there's actually 23, 24 design patterns. You'll find that most of the code you write, if it's clean code, ends up falling into one of these buckets. And that's all there is to design patterns, really.